Hello everyone, today we are going to solve problem 25 of chapter 18. The 30 kilogram disc is originally at rest. I mean the initial velocity, initial angular velocity is 0. And spring is unstretched, so there is no potential energy or no initial force. A couple moment M 80 Newton meter is applied to the disc as shown. Determine how far the center of mass of the disc travels along the plane before it momentarily stops. So that's interesting. It starts from rest and it stops. So the initial and final kinetic energy are 0. The disc rolls without slipping. So we can write the work energy equation. The initial kinetic energy, the work that we do on the sample, would be the final kinetic energy. It starts from rest and it's going to stop at the end as well. So we don't have any kinetic energy. All we have is the work that's done on the sample. So we have two components of work. One, the work that is done by the moment, and also the work that is done by the spring. Let's find the work of the spring first. So we talked about that the work of a spring is always negative because the force is always the opposite direction of displacement. So it's half K S squared, where K is the spring constant. So half of 200 S is the displacement. So negative 100 S squared. And then the work of the moment is m d theta or m theta here. So if you look at the two work, we have two unknowns, s and theta, and then we have one equation. But s and theta are related. If we have more rotation, more theta, we're going to have higher s. If I draw here, you will see if this is r, if this is theta, this is your s. So r theta equals s. So instead of theta, I could write s over r. And I know the radius of the disk. And this r theta equals s is only valid for rolling because the distance depends on the rotation. It doesn't have any translational component. The problem specifically indicates that we have rolling without slipping. So therefore um would be m, which is 80. Instead of theta, I'm gonna write s over r. S and r would be 0.5. Therefore, I have 160s. This one is positive, and this component is negative. According to equation, the work done on the sample would be 0 between the first and final instant. So 160s minus 100s squared would be 0. If I factor s, I have 160 minus 100s equals 0. I have two solutions. S0, which would be the first instant, that would be the obvious answer. Also S 1.6 meter. So this is the answer that we are looking for because it starts and then it stops. So after 1.6 meter, the couple moment does not have enough power to stretch our spring further, and spring force would pushes our disc back, because as S is increasing, the work done that is done on the opposite direction also increases. This problem was interesting because we didn't have any kinetic energy.